So hello everyone. Today we're going to be doing an interesting geometry slash calculus problem. Namely, if we're given a triangle ABC such that the angle next to the vertex A is 30 degrees and the sum of the sides C and B is equal to 100, we're supposed to find the length of the side C or AB of this side right here, such that the area of this triangle will have a maximum value. Okay, so how do we go about doing this? Well, I'd like to start by taking my trusty ruler, and I'm going to place it at 90 degrees right here. Okay, and this is the height, and this is the height, I'll just call it h, of our triangle. So if we use some basic knowledge about geometry, we know that the area of a triangle, of any triangle, is equal to 1/2 times a side, I'll just pick B in this case, and times the height to that side. Okay, so that's B times H. Now let's just go ahead and try and express B and H as functions of C. So from the triangle, okay, I'll just call this point H, from the triangle ABH, we see that it's a right triangle, right, because this is the altitude or its height, and so we can use the sine function. So sine of 30 degrees is equal to H over C. So since sine of 30 degrees is equal to 1 over 2, which is equal to H over C, when you cross multiply, we get that H is equal to C over 2. Okay, that's part of our answer. Now, we want to do the same thing with B, and we can actually do that from this condition right here. Why? Because from here it follows that B is equal to 100 minus C. Okay, and let's just go ahead and plug these in here. So we'll get that the area as a function of C is equal to 1 over 2 times 100 minus C, so 100 minus C, and times H, which is just C over 2. Or when we expand that, we'll get 100 over 4, 100C over 4, which is just 25C minus C squared over 4. So we've expressed the area of our triangle as a function, and it's a parabola nonetheless, as a function of the side C. Now it's pretty much just calculus from here. So d over dc. So a prime, we're just differentiating both sides, taking the derivatives. So we'll get that a prime is equal to 25 minus 2c over 4, which is just c over 2. And if we make this out to be 0, which is one of the conditions that we must meet, that must be met in order for there to be an extreme, then we'll get that c is equal to 50. Okay, c is equal to 50. So we've got our stationary point. And if we go ahead and draw a table, it's going to be a relatively simple table. Minus infinity, 50, plus infinity. Here we're going to have a prime, and here is a. So if c is less than 50, if c is less than 50, then we'll have a positive value. At 50, it's exactly equal to 0, and from here, it's going to be a negative value. Because the first derivative is positive, the function is ascending in this part, and it's descending in this part. And from here, we can see that it has a maximum at the point c is equal to 50. So that's the value that will give us a max, and that's the value of c that will give us the maximum value of a, or the surface area. So let's just go ahead and compute that now. So a max as a maximum area is equal to 25 times 50 minus 50 squared and everything over 4. And once we compute this, we'll get something around, we'll get 625. So the maximum area of this triangle is equal to 625 units of measure. So I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.